Hey everyone, in this video let's go through question 78 subsets on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, we're given an integer array of nums, they're unique elements, and you want to return all possible subsets, which is known as a power set. The solution must not contain duplicate subsets, and you want to return the solution in any order. Now, just before I get into this video, I want to say that for any types of problems where you want to generate all possible things, maybe all types of formulas, all types of parentheses, all types of subsets, all types of permutations, this is known as a backtracking type problem. Backtracking type problems are basically a subclass of recursion type problems, but the only difference is that recursion will take a bigger solution and it will go down, go down, go down to get a smaller solution, and basically use that smaller solution to come up with the main solution, which is usually just one thing, one type of answer, right? Backtracking is similar, but instead it will use a smaller solution, such as just maybe this one here, and then we'll globally expand on that one, form more and more solutions like you see over here. The main difference is that backtracking, the types of problems in backtracking are usually exhaustive searches. You're basically looking through everything and you want to generate all types of answers. In recursion, you might still look at everything, but you only generate maybe one type of answer, right? Like total depth of a binary tree or something like that, right? A backtracking type approach would be like generate all types of depths, right? Anyways, so that's just a type of question, and I want to kind of make this video about that. So this one will be a slightly longer video, but I want to kind of go through my approach to how I solve these backtracking type questions. So anyways, let's just get into this one. If you take a look at this one in nums, we're passed in 1, 2, 3, right? And these are the list of subsets that we can form. First thing you'll notice, if we have 1, 2, then we won't have the subset 2 of 1, 2 and 1, because it's essentially equal to the same thing. That's what it means by duplicate. But basically, what do we kind of notice about here? Like, what exactly is a subset if you think about it logically? Well, if you look at this one, we have the item 1, but we don't have 2 and 3. If you look here, we have 2, but we don't have 1 and 3. Here we have 1 and 2, but we don't have 3. Here we don't have any of them. Here we have all of them. Here we don't have 1. Here we don't have 2. Here we don't have 2 and 1. If you think about it, basically, for each one of these, it's kind of like a choice, right? Like of whether I want to include the rest of the elements or I don't want to include the rest of the elements. Here, I could have made the choice to include the 3, in which case I made this. But if I didn't want to include the 3, then I made this. So it's kind of similar for like all of the elements. We're basically choosing whether we want to include it or we don't want to include it. And so this is kind of how we're going to solve this problem by considering those two cases of whether we want to include an item, whether we don't want to include an item. And let me kind of jot this down on Paint just so it's kind of clear. And I don't like drawing out too much like trees, but I feel that tree is the appropriate way here. And I don't want to spend too much time on the tree because I want to explain the coding, but let's just see what we can get at just using a tree, a visual type approach, right? So what do we have? So first of all, we have the 1, 2, and 3, right? I will just space these out. Okay, so 1, 2, and 3, right? So first thing we do is we're on index 1, right? So we're on index 0. So it's considering this 1 over here. And as I said, we have two options, whether we want to include the 2 or whether we want to include the 1 or whether we don't want to include the 1. Okay, let's say we want to include the 1. If we want to include the 1, then from our list 1, 2, 3, currently what we have is we have 1 added to the subset, right? If we don't want to include the 1, then what do we have? Well, we have 1, 2, 3 again. But instead, we'll be considering 2 and 3. We won't be considering 1 anymore. So let's start with left-hand side here, where we consider the 1, right? So if we consider the 1, then again, we're considering the 2 and the 3. But what are we doing here? So first, we will start to consider the 2. So let's consider the 2, whether we want to keep the 2 or whether we don't want to keep the 2. Okay, so let's say we want to keep the 2. If we want to keep the 2, then what happens? Well, then from our list, our subset was initially 1, and now we said we want to include the 2. So what we will do is we will form 1 and 2. If we don't want to include the 2, well then we still have the 1, right? We still have the 1 added. So our subset remains 1, 2, and 3, where we only considered the 1. Now we've considered items 2, 1. The remaining one is 3. So again, we have the choice. Do we want to consider 3 or do we not want to consider 3? Similarly here, we'll have the choice. Do we want to consider 3? Do we not want to consider 3? So in this case, if we want to consider 3, what do we have? Well, we have 1, 2, 3, right? And I'll actually just write 1, 2, 3 for all of these, and we'll fill them up 1, 2, 3. So in this case, in the left-hand side case, in this one over here, if we do want to consider 3, well then initially it was 1 and 2, but now if we consider 3, it's 1, 2, and 3. If we don't want to consider the 3, well then it's just 1 and 2 as it was before. Before here, we just considered the 1, we didn't consider the 2, and now we want to see if we want to consider the 3. Well, if we do want to consider the 3, then we'll have 1, and we'll have 3 in the subset. If we don't want to consider the 3, well then we'll just have 1. So notice how we're forming actually subsets here, right? If you think about this is one subset right here. This is another one, just a 1 and 2. This is another one, just a 1. I'm sorry, the 1 and the 3 really. This is another one, just a 1 in itself. Now here, remember, we're just looking at the part where we consider the 1, right? If we don't consider the 1, then what do we have? Well, we have 1, 2, and 3, but really, we just want to look at the 2 and 3 because up till this point, there has been nothing considered. So let's take a look at what happens here. So let's say for the 2, we have two choices again. Either we consider the 2 or we don't consider the 2. If we consider the 2, what happens? Well, if we consider the 2, then our 1, 2, 3, 1, 2, 3, and let me just make these smaller. And actually, I will just space this out a little bit more. So let me actually just clean this up a little. I will remove this here, and I will put this all the way here. And let me just remove this, and let me just actually connect this. Great. Okay, so in this case, we considered the 1, and we arrived at these following subsets. In this case, we didn't consider the 1, but now we're on the 2, right? So we have two choices again. Do we want to consider the 2? Do we not want to consider the 2? So let's say we want to consider the 2. Well, if we want to consider the 2, then what happens? What does our subset become? Well, from the 1, 2, 3, our subset is now simply the 2. It doesn't include the 1 because we didn't consider the 1 before. If we didn't want to consider the 2, then what does our subset become? Well, it just actually remains as empty. So all we're left with is the 1, 2, 3 as before. 1, 2, 3. Okay. So now in this case, what do we have? In this case, we already looked at the 1, we already looked at the 2, now we have the 3 left. So we're going to take a look. Can we consider the 3? Can we not consider the 3? Similarly here, we already looked at the 1, we already looked at the 2. Can we consider the 3? Can we not consider the 3? So now, we're arriving on our final set of subsets. That will just create the 1, 2, 3, 1, 2, 3. And let me just 1, 2, 3, and finally 1, 2, 3 again. And we're almost done the graph, just bear with me, we're almost done the tree. Basically, over on this side, we didn't consider the 1. Here we considered the 2, and now I'm asking, do we want to consider the 3? So sure, let's consider the 3. So then here, the subset becomes 2 and 3. Here, if we didn't want to consider the 3, then our subset simply remains as 2. Here, we didn't really consider anything. We didn't consider the 1, we didn't consider the 2, and now we want to ask, do we want to consider the 3? Sure, let's consider the 3. Here, if we didn't want to consider the 3, then we didn't consider anything. So we have the empty subset here, essentially, right? So what do we have? Well, if you take a look at it, we have all of the subsets that we formed. We have the subset 1, 2, 3. We have the subset 1, 2. We have the subset 1, 3. We have the subset 1. We have the subset 2, 3. We have the subset 2. We have the subset 3. And we have the subset of the empty. And you notice that this is exactly 8 subsets, which is equal to 2 to the n, where n is the amount of elements, 2 to the 3. So now that we have this, let's translate this into code so we can better understand how to actually code these types of problems. And you can see that the solution we got, or basically just drawing it out, is equivalent to the one that is in the example over here. So let's take a look at how we can actually code this up. And I'll explain my coding process. And again, this video will be a little bit longer, but bear with me because it's the first one in the subset or in the backtracking area. So I want to make sure that we understand this. So usually in these types of questions, what you usually do is you create some sort of result variable, and then you have a recursive call, which will populate this result variable, and in the very end, you return your you return your result variable. Now here, in my helper, so what do I need to pass in? Well, I need access to the nums, right? I need access to the nums. I need access to the result variable. If you also notice here, notice how at different iterations, we're at different like calls in the recursive stack. Each of these is a recursive call. We're considering different values in the loop, in the array, right? For example, in this one, initially we start off at index 0, but here we're considering index 1 for both of these. At this recursive call, we're considering index 2. Even though like initially we were considering index 0, now we're considering index 2. What this tells me is that I need a way to basically force my loop in my recursive call to start off at a specific index. It can't always have it start off at 0. So this is kind of something new, right? Because like in recursion, when you usually have for loops, they probably just start off at the same location. But here it's going to start off at a different location. Again, here we start off at location 0, and then at this recursive call, we're going to start off at location 1. And then if we don't consider it, we're going to start off at location 2. So those are some of the things we have to consider. The one thing we want is maybe like an index variable, like a loop index variable, right? The final thing that we need here is, if you notice, what we are doing is we are populating subsets in the recursive call, right? But we don't arrive at the final answer until the very end, the very end of the recursion, like at the most bottom level. So at these individual levels, what we are doing is we are basically adding onto an existing subset. So we need a variable to keep track of that. So this variable I'll just call cur, and cur will be like my existing subset, right? Cur will be my existing subset. Now, one thing we want to do, essentially, is I will go ahead and loop, right? I will go ahead and loop. Now, where will I loop from? Well, one thing I need to do is I need to loop from not 0, but actually the index that's passed in, right? I need to loop from the index that's passed in all the way to the end of nums, right? And what do I want to do here? Well, basically, I want to call my helper on what? Well, nums doesn't change, res doesn't change. Index, what does index become? Well, if you think about it, if my index initially at this point was 1, right, referring to the 2, then when I'm doing my recursive, I'm sorry, here, if it was 1, when I'm referring to the 2, when I'm doing my recursive call here, it has to be the next index, index 3. So that's what we will do here. We will increment index by 1, which is actually not index plus 1, but I plus 1, because I is the current index now. And then cur. Well, what does cur become? Well, here, cur is going to become cur plus whatever element we're already on, right? Whatever element we're already on. So this one, what we're doing essentially here is that we are adding to cur our existing element. Now you may ask, what about if we don't want to add the element? Then what happens in that case, right? Well, in that case, we simply don't consider it. What will happen here, for example, is that if we are on, let's say, the first element or the 0th index, right? The 0th index we are in, then in this one, we will add in the recursive call in which we consider the first index. But once that returns, cur at this point will just be whatever was initially passed in, which is just the empty set. And then I will become 2, and then we will consider the empty set plus whatever is at the second index, which is 3. So in this sense, cur and nums will basically be all we need here to create our recursion. Now, everything of this is good, but we need to do one more thing. Like, where do we actually fill up the res, right? Where do we actually fill up this variable over here? Well, it turns out that we can actually just do that when we start our recursive call. Well, if you think about this, what we are doing here is if I can do res.append cur, right? Something like this. Well, what exactly are we doing now? Well, during every recursive step, right? Every recursive step, we're generating the subsets that needs to be formed, if you kind of think about it. So here, the subset will just be 1, it'll be 1, 2, and then down here it'll be 1, 2, 3, etc. So at every recursive step, we are generating the subsets that needs to be formed. So every time we do the recursion, we can add the existing subset to our list of valid subsets. So if I go back here, exactly what we're doing. So res.append cur, and then I'll explain this in just a moment, but you can see that this is exactly what we needed. Now, if I go ahead and I fill out these variables here, the nums is nums, res is res, index will start off at 0, cur will just be an empty list, and if we go ahead and we run the code here, you notice that it passes. If we go ahead and submit, you notice that it passes. Now it turns out that actually this variable here, like this thing over here, this basically creates a deep copy of the list. Now, you don't actually have to do that in this case, I believe. If I go ahead and run this case, and then I submit it, we don't have to actually create a copy here. That reason is because of a little bit of how Python works. So if you take a look at what's actually happening here, right? So let me maybe put the paint just on top of this, or we put it beside here so we can actually see what's happening. So initially, like when we are considering this first index over here, and what we are doing is we are performing a recursion on I+1. So now we're down here, and we are actually considering, what are we considering? Well, we're considering the one item here, right? Like this first index over here. We've already added nums at I. So now we've added nums at I, and now we're doing a recursion on this level over here, this downward level over here. Now, basically, what happens here is that once we do a recursion, first thing we do is we add this single one subset to our list of answers, and then we start off at index 1, which is index 2 here, and then again, what we do is we add on this element, which is the second element. So then we add on 1 and 2, and then again, we do another recursive call. So then we'll add on 1 and 2 to our list of res, so our final variables, and in the very end, we'll go back to this final element 3, and then we'll add it on, and then simply we just go back. So once we add on the 3, there's no more recursion to be done, right? The I+1 here, when you do it, you basically add it, but you'll be outside of the loop. So what will you do? You'll finish this loop, and so from here you'll return back here, but notice that we're already considering index 3. So really here, there's nothing else to do. So again, we'll return back. Now notice cur at this point will just be this list over here. It'll just be this one list over here. So then at this point, we already considered the second I, right? We already considered I equals 2. So now, I equals 1, which is the second element here. So then we will consider I equals 3. I equals 2, which is the third element here, and then we will again create this and create these two elements. So notice how that's how we're actually creating our subset. Now, this way of doing the subset creation is actually not too good in that we are adding cur and then we are adding another element right here. This is actually O of n operation. The way it's usually done is to add to cur ahead of time, like this. Then you just pass in cur, which is the new element, and then you actually pop the last element, which is just like this, and then you pop it from the cur. So this is the same thing as what we did, but now, because of the way Python works, when you add an element to a list, every single recursive call, even if you backtrack, it will still have that same element you added. So it's like even if we arrive at 1, 2, 3 and we go back, cur at this point would still equal 1, 2, 3. And so that's why we have to pop from the list to kind of remove that 3. We didn't have to do that in the way that we were doing it before, because in that one we're creating like a brand new list every time, right? So when you backtrack, you just go back to the old list. But here, if we are using the existing list and simply overriding it, then if you go back, because of the way Python works, and when you pass by, I forget if it's passed by memory or passed by value or passed by reference, but lists do not change in recursive calls. They remain the same. And so that's why when you come back, you actually have to pop the last value. And that's why here, if I was to do this, if I was to maybe just run the example test cases, this in itself was actually fail because here, cur, we need to create a copy of cur here. We need to create a copy because as I said, cur, when you append to a list, it will append it basically in all locations. So you have to create a copy of cur here. So now if I just go ahead and click submit, now we can get the proper answer in the faster way. Just to kind of, okay, I realized I didn't really explain why we need the cur and then this copy over here. Like, why are we adding a copy of the existing list instead of that list in itself? And it's simply because of the way Python works. So if I was to go through this, so let's say we had res as an empty list, and let's say at one point the subset was equal to maybe a is like 1, 2, 3, and another recursive call, a is something like 4, 5, 6. And both of these we add directly to res, right? So we'll add in a, and then we'll add in b. If you take a look at res, it's exactly as we look like. It's exactly as we expect. But you can see here that when you return, we do a pop, right? So if we do something like b.pop, now b is obviously 4 and 5, but you wouldn't expect res to also be 4 and 5, but it is. And that's simply because lists work a little bit differently in Python and actually in most languages, because it's always based on the memory value. So here, that's why we need to add a copy. So basically, if a is 1, 2, 3, and then b is 4, 5, 6, and to res, we append a copy of each of them, right? So now res is this, and you can ignore the first two. So I think res should just be this, right? Res is just this much. Now, if you take a look at b and we pop it, Sure, B will change, but res will not change. And that's the main difference, and that's why we need this. I hope it helped.